Okay, in part D, we're asked to use the Taylor series for f about x equals 1, and I have it listed below, to determine whether the graph of f has any points of inflection. Well, if that's f of x, then the first derivative would be bring down the derivative of 1 is 0, then bring down the 2 at 2 times x minus 1, reduce that exponent by 1, and simplifying this would give me basically just x minus 1 as the leading term there. And I could kind of write that as being to the first power. Now then the second derivative would be the derivative of x minus 1, which is just 1, then plus 4 times 3 times x minus 1 squared over 3 factorial, and then plus 6 times 5 times x minus 1 to the fourth power over 4 factorial. And when we find this at x, we try to find out where this will equal 0, and it turns out that it never equals 0 because when we plug in x equals 1, all the other terms will become 0, but it will always be, the value will be 1 when x is equal to 1. Actually, each of the terms will be positive there because of the exponents, and since we're adding everything together, this will always be greater than or equal to 1. And so it can never be 0, and so there are no points of inflection. Now, if in the event we were looking for the general term of this second derivative, you might find that just by taking the derivative of the general term, the second derivative of the general term of the original function. So for example, the derivative of x minus 1 to the 2n over n plus 1 factorial, we'd bring down the 2n, and the new exponent would be to the 2n minus 1, and n plus 1 would still remain. That's basically a constant. And so that would be the first derivative, and then the second derivative would be again to bring down the 2n minus 1 and make that a factor, so we have 2n times 2n minus 1 times x minus 1 to the 2n minus second power all over n plus 1 factorial. And that would be the general term. It's not asked for in this particular problem, but just in case you were thinking about how you would go about writing that, it might be easier to find the general term by taking the second derivative of the original general term. And then where would the series begin? Well, we would begin at whatever it takes to make that term equal to 1. Since the first term in the series is a 1, then we could plug in and find out. We would need to get x minus 1 to the 2n minus 2 would have to come out to be equal to 1, which would mean that exponent would have to be equal to 0, which would mean that n would have to be equal to 1. And when n is 1, the x minus 1 just becomes 1. The denominator becomes 2 factorial. We get 2 times 1 times 1, or 2 over 2 factorial, which gives us our value of 1. So this series would begin at 1. And so this would be the series that represents the second derivative of f of x. Alright, so only the answer that there are no points of inflection are required is required here, and that sums up and completes this particular problem.